Welcome, everybody, to the Council of Data Facilities ESIP session. We're going to do a little introduction of what the CDF is, as we're a new cluster here at ESIP. And then we'll do a sort of a mock meeting that's similar to what we have at our meetings. We'll have a discussion on the science-on-schema.org, some presentations on that, and then Kenton McHenry will give a talk on the DeCODER project. Maybe first we could, since we don't have a huge number of people, we could go around and give a short 10-second introduction. Sometimes it's nice. I'm Nick Jarbo. I work for the EarthRef Consortium and run the Magic data repository and Fiesta EarthCube projects, and I'm in Glenwood Springs. Maybe we'll just go down the list. Karen?
Yeah, thanks. My name is Karen Stocks. I'm at Scripps Institution of Oceanography, and I'm from the Geological Data Center there. Oh, and I'm co-chair.
And I'm the chair. Chad?
Hi, I'm Chad Langto, first-year community fellow and second-year graduate student at University of Tennessee in Knoxville, Tennessee, in the School of Information Sciences.
Thanks, Chad. Kenton?
I'm Kenton McHenry, Associate Director for Software at the National Center for Supercomputing Applications and Technical Lead for the EarthCube office.
Doug?
Hi, I'm Doug Phils with the Ronin Institute, and I work with the EarthCube office and a few other groups.
Fran?
Hi, I'm Fran Lightsome. I'm at the USGS office in Woods Hole, Massachusetts, where I'm project owner for the Coastal and Marine Geoscience Information System or something like that, which is digital data. And also we have a large data library of not yet digital data.
Thanks, Fran. John? Well, maybe he's muted. Armin, if you'd like to do an introduction. So we'll go to Shelley.
Hey, Shelley Stahl, the American Geophysical Union, and really good to see everybody.
Thanks, Shelley. Kirsten?
Hi, I'm Kristen Vanderbilt, and I'm a data scientist with the National Park Service Inventory and Monitoring Division.
Thanks. Colin?
Hi, I'm Colin Smith. I'm with the Environmental Data Initiative.
Mark?
Hi, I'm Mark Parsons. I'm with the NASA Science Data Office and the University of Alabama, Huntsville.
Thanks, Mark. James? We'll go Sky, if you, oh, James. Sky, if you want to.
Sky Bristol. I'm the Senior Advisor for Data Science with the USGS Energy and Minerals Mission Area.
Thanks. Mike?
Mike Bobek, NCSA, working on GeoCode's now DeCODER project.
Nice to have you. Adam?
Hi, oh, sorry, go ahead. I misheard. Go ahead.
This is Adam Shepard from BecoDemo, Woods Hole. Good to see everyone. Thanks.
Jessica?
And I'll say I'm Alan Pope. Sorry, I misheard you before.
Right,
Alan Pope with National Science Foundation Program Officer for Polar Cyber Infrastructure, but work with your EarthCube program as well.
Great. Thanks, Alan. Jessica?
I'll assume it's Jessica Burnett you're asking for, so that's me.
Yeah.
I'm
just another one added on.
yeah, I saw one pop up in the chat. I'm with NASA headquarters in the Ecological Conservation Applications area.
Thanks, Jessica. Gary? And we'll go with Jessica Morgan.
Jessica introduced herself in the chat. And
Oh,
so
okay,
did
great.
James. So we have two
Thank
folks
you.
over there.
Perfect. Okay. So let me share my slides here. We'll get started.
Should we take a moment to ask if there's anybody who has slid in that we missed with the self-introductions?
Sure.
Yeah,
free to-
hi.
I mean,
This is
people
Bob.
keep coming in.
Go ahead.
No, Bob, go.
Oh, sorry. Thanks. Yeah, this is Bob Downs, and I'm representing CDAC, the NASA CDAC, Socioeconomic Data and Application Center, the ESDIS Standards Coordination Office, and Astromat. Thanks.
Yeah, and I'm Martin Zoll. I'm representing Quasi and TitlesShare and HIS repositories.
Yeah, and I'm Frank Nietzsche. I'm representing the US Antarctic Program Data Center.
All right. Well, if we have covered everybody at this point, thanks for coming, everybody. Today, we're running a session sort of introducing the Council of Data Facilities to the ESIP community. I'll give a short history of the Council of Data Facilities, and then we're going to have some topic discussions, one on science on schema.org, and then one on the DeCODER project. Here's just sort of an overview, but you can see that in the what we're going to go through today. So the session welcome. I'll do a short talk on science on scale.org. Not sure if Simon is going to be able to make it today. We may have to skip that talk. Then we'll do an implementation by the Magic Data Repository, then some discussions on the science on schema.org metadata system, and then Kenton will give a talk on the geocodes. So a brief overview of the Council of Data Facilities. So Council of Data Facilities came out of the EarthCube project, which many of you may be aware of. It's an NSF funded project, decade-long project, which main idea was to encourage cyber infrastructure in the earth sciences, and funded a lot of projects and ideas, and tried to bring communities together and see what people could come up with. So the Council of Data Facilities were a group of data facilities and other entities that were interested in data facilities that sort of joined together. They created a charter and tried to be a place for sharing ideas, initiating projects, and being a voice for the data facilities, mostly in NSF, where there was not a lot of structure around data sharing, unlike some of the ESA partners like the USGS and NASA and NOAA. But other people joined also. EarthCube project has wound down. They supported us through those years, and now we've moved over to ESIP as a cluster. We're still sort of trying to find our way exactly and what we want to be in the future. But we feel that it's valuable to have this place where data facilities can come together and discuss ideas and implement projects. We meet every third Wednesday of the month at 3 p.m. Eastern. We welcome everybody to come that's interested. And there's there's the link to our ESIP description and webpage. I'm the chair, Nick Jarbo, and Karen Stocks is the co-chair, and we welcome you to this session. In the spirit of the way we usually do things, if anybody has any questions, please feel free to ask them. And usually we, I encourage people to stop in the middle of my presentations anyway, if there's a point that they want to talk about. So if anybody had any questions about the Council of Data Facilities, Karen and I would be happy to answer those now, or we'll just continue on to the next presentation. Okay, don't see any hands up. So I'm going to give a short talk on using science on schema.org as an Earth Science metadata standard. This is based on Google's schema.org metadata standard for describing web pages for Google search indexing. Here's a little diagram that we have in the document.
Nick, I think we're not seeing what you're seeing.
Okay.
Just
Sorry,
a sliver of your screen. Can you try again? I don't know if you shared just your PowerPoint.
How's that?
Looks good. Yep, looks good.
Great.
Okay.
Yeah, that's good.
Okay. So schema.org, Google originally, when it was starting, would just scan web pages and parse the HTML and try to get information on various websites. And they realized if they wanted to do more accurate and sophisticated search results, it would be very useful to have a metadata standard that people could put on their web pages that were precise and machine readable in a standardized way. So they created schema.org with various types and properties with fields and defined data types. And so if a bunch of hotels use this metadata, they could get very accurate information and create, these sort of search results like you see over here with locations and prices and so on. So this is very useful, but for science and data sets, wasn't quite as well designed, but they created a data set object type recently, and Google has set up a search portal for data sets at dataset.research.google.org or .com. And so they are trying to implement, and they have implemented a data set search portal. It's not well published and promoted, but it exists and it's quite nice. But this standard, to get into it, it's very encompassing and complicated, and so the people in ESIP and EarthCube got together and decided that they tried to publish a standard and documentation for Earth science repositories to make it easier for people to use it and implement it. And so Adam Shepard is currently leading this cluster. Thanks, Adam. And there's a little blurb on the docs that I thought describes it well. Provides guidance for repository operators and others to follow consistent conventions to provide schema.org markup in dataset landing pages to improve data discovery through search engines. And many of the people in this cluster also work with the work on the EarthCube's geocodes project and use standardize for their project also. So here's a list of the various parameters that are described in the documentation on how to put the metadata on your data sets. You have sort of standard common properties, keywords, identifier of the data set, variables in the data set, how it's distributed, dates and geologic time, spatial coverage, roles of people, the publisher and provider of the data set, who funded the data set, the license, and so on. So there's a large number of ways you can describe your data set, and these are explained in the documentation. So here's an example from the documentation. This is the common properties, sort of the general properties of a data set that's recommended by Google that you have in every data set. Name and descriptions are required. Then you would want to have a URL, maybe a pointer to somewhere else where the same data set exists, if that such a thing is out there. Version number of the data set, whether you can access the data set for free, keywords, data set identifier such as a DOI, and what does a data set measure? And then for each of these types, there's a sort of a diagram that's nice once you understand how to read it. So the boxes are the data types. The arrows, the labels there are fields for that data type, which can also be another data type. And then the circles are the field types. So if you're wanting to put this into your header, we use a JSON LD to describe it. And this is sort of how it works. This is a section from the docs where they're explaining the identifier field. And so generally you have at the top of the header a context, which is the schema.org documentation. Then you describe what this is. This is a data set. It's not a creative work or some other type. Name, description, URL, and so on. And then this is highlighted, the identifier. It could be a text field, but we prefer an object description with more values. You can see there the type, it's a property value, and then these other fields. And the documentation along with this describes why a text field is not, the most appropriate. We want to have a value, a URL, and an ID, which makes it easier for search engines to parse the data and so on. Another thing science.schema.org has done is added extensions to schema.org for earth science data sets that are quite useful and necessary to describe them, but aren't in the schema.org schema. So here we've used Queensland Research Center descriptions for timescales. We use GeoSchema's description of unit abbreviations and the W3 descriptions for time and data types to describe a geologic age. So here the data set has a text description. It's the eruption of the Bishop Tuff 760,000 years ago. But it'd be nice to have a very well-defined, machine-readable description of that age. So here we've described it as an instant in time, and it has a position, in this time scale, which is millions of years ago. And that position is then described as a decimal and has the value of 0.76 with a time unit of millions of years. And so we've added this to our recommendations, and there are others that we have described also. So here's what looking at a web page on the MAGIC database, sort of the top of the header here. So we've I'll describe this in more detail later, but we've got some of these fields and properties. And so once you've labeled all of your data sets with the science-on-schema.org header, you can, Google can scan you if you tell them where your sitemap is, which is a list of all your data sets that have headers. It'll happen more quickly. And then they go through it, reads the header, and then it can produce a search. This was on Steens Mountain. One of the results was from our data repository, and it has a link to the data set, a nice map, the variables measured, description, and so on, formatted in a nice way that people can find. And finally, just like to say there's a science-on-schema.org related session tomorrow, extending science-on-schema.org for the international compatibility at 1:30 Eastern. And I'd like to open it up for questions. And Adam and Doug and the other people that are in science-on-schema.org cluster, feel free to answer any questions that you feel you're expert at.
Nick, how would you like to take questions? Should people put their hands up or speak or in the chat?
Let's see. Yeah, raise hands is good. What do you think? I don't see any. Okay.
I actually put mine up. I do have a question.
Okay. Yes.
So if you have a community that needs to express something that's kind of special or important to them that isn't covered in the more general schema.org framework. So for example, in the marine community, depth in the water column. I don't know if that's accommodated in the geospatial description. That's an important concept, or for those that work with biological data, taxonomic names. What's the appropriate way for a community like that who wants to work with schema.org but wants to make it work for them to sort of move forward?
Well, I mean, what we would suggest is come to one of our meetings if you don't see it in the documentation, and there may be some way of doing it. Maybe Matt, do you want to grab that?
Yeah, I'd take a quick pass at that. I think one of the advantages of the schema.org approach is that the vocabulary is extensible, and by using JSON-LD, it's very easy to attach new terms and properties on. So I think that there's a couple of ways a community could quickly take care of that. And I think Nick's right that one way is to talk as a community and find out, how we want to do it together. But there's also, if there are already existing vocabularies, it's certainly reasonable to use those within your records. And so like you could look at schema.org itself to see if there's a property that might not already be in the SOSO guidelines and that you could utilize. You could look at DCAT or one of the other dataset vocabularies and see if there's a property there that's appropriate for you. Or you could pull in a disciplinarily specific vocabulary and try to use that. But yeah, I think if there is some uncertainty about what terms should be used and how they should be structured, I think it would be great to open a conversation with the cluster and try to reach some agreement on that. The more disciplinarily specific you get, probably the less likely the cluster itself might have the answers to that. But I think getting the community conversation going is a good way to start.
And I'll just throw in from a community director perspective that it is a very, very friendly group that wants to help help folks get on the ladder of adopting. And along those lines, I want to highlight a question in the chat from Shelley Stahl about how adoption is going. I wonder if anyone can speak to that.
Well, this is Doug. I can just make with a couple of quick comments on that. I mean, I think we see a lot of interest in various communities, right? So we see like Polder is pulling in some of the approaches that are being used here. I know that the UN Otis with the Ocean Info Hub is also looking at science-on-schema.org and following the guidance there for data set. And the overall pattern that is utilized in terms of structured data on the web is gaining traction in other groups like CCADI in Canada or the Internet of Water or other groups. So I think there's a lot of adoption or a lot of growth taking place in that regard.
Thanks, Doug. All right, well.
Moving on, there's another question from Mike Daniels in the chat. I don't know, Mike, you have your hand up. Would you like to say it out loud?
Oh, sure. Yeah, I didn't know if you saw it. Yeah, so a lot of you know I was involved in the CHORDS project for time series data, and involved in field programs. And one of the things in field programs, they look for as much data as they can to put a picture together of the environment. Sometimes these sensors are out there and nobody knows about them, and they're streaming data in real time. So my question is about the spec for time. Does it have room for streaming data? Data that are instantaneous, and maybe things like the sample rate and things like that. So that people are aware that these data are streaming in a region that they're studying, and can access them.
Well, I believe that's one of the issues that we've been working on, and I don't think there has been a satisfactory conclusion to that. Would that be fair to say? We recognize that that's an important type of data, but I don't think we have formally described what we do that as.
I probably should bring somebody along on the cluster to talk about that.
Yeah, people have brought it up, and it's an important thing, but something to think about. We have added the new W3 time vocabulary examples for geologic time, so there might be something there that can be adapted for that situation, but I don't think we've raised that issue recently for discussion.
Thanks. Matt has his hand up.
Yeah, Matt.
Yeah, I just had a quick comment about that issue, and the one that Karen raised is this issue of like, how do you get more detail from in various disciplinary ways or for certain types of data? And I think one of the things we should try to keep in mind is probably that schema.org is meant to be a relatively lightweight web-based registration of a data set. And in many ways, I don't think it's meant to replace disciplinarily specific metadata standards that have a lot of the detail that you might be talking about. And so at least, there is a place within the schema.org record where we've identified how you can link out to a more detailed record in another vocabulary. So if you have an ISO record, or you have an EML record, or you have some other record in the biological sciences or something like Darwin Core, you can point to that and say, here's further more detailed metadata in the disciplinarily specific vocabulary that's sort of in use. And I think that's an important thing to do, because it is, you're embedding this metadata on web pages, and I think largely following Google's rules. And when things get too long and complicated, you actually sort of suffer some challenges sometimes with Google. So if we had really big data sets, I'm not sure how Google data set search and stuff like that would work with it as well. So.
Okay, unless there's any more questions here, we can go on to the next talk. Simon Goring was planning on giving a presentation on neotoma, but he wasn't able to make it today. So I will go on with the presentation on how at Magic we implemented the scienceonschema.org metadata. Let's see here. Okay, so I'm going to do a little discussion, talk on the science on schema.org implementation at the Magnetics Information Consortium's data repository. We're a data repository for paleomagnetic, rock magnetic, and geomagnetic data. We've been around for a couple of decades at this point, with lots of different technologies through the years. Here's the current Magic group. PIs Anthony Coppers, Nick Swanson-Heisel, and Max Brown, with Josh Feinberg, Kathy Constable, Lisa Tokes, myself, Rupert Manette, and Pete Solhead, also heavily involved in the project. Here's a Magic homepage. So we have, a database that has been working on a lot of the FAIR principles through time, and we try to be as open, accessible, findable, and reusable as possible, and have helped sort of push those views through various avenues. When we decided we wanted to put up some metadata for Google and also for other projects, it's a way of people can scrape your site and get the information. We also have an API, but people use different technologies to get data. So when we started our process of putting the headers on there, we already had for each contribution a summary in Elasticsearch of metadata for the contribution. So the tables would be summarized. We'd give an age, each location had an age, and those would be put into a range. Various other descriptions like rock types and what type of rock, lithologies, and the measured data were summarized already. So what we had to do was just take those summary, that information, and add a few more and put that into a header. So here's sort of here's an example of our header. It's in the script tag and in the data in the web page. As you can see here, you've got the context, you've got some outside source data descriptions, then the data set, our minted DOIs, and so on. This was, it was nice to go through this process, especially, there were some things that we hadn't been recording yet, and this focused us on some valuable metadata that we should have been collecting from people. Here we have our geologic age summary. So we've used that guidance to describe the age range of the data and also the spatial coverage of the data. And we also put in our sort of subdomain specific measured values. So we have paleointensity descriptions, sample orientation, stratigraphic height. So here's where you could put in height as a property value, sort of generically. And so when we were going through this process, we found that we needed to add more inputs to fully describe the data set in the way we wanted. And we have this interface where you can insert some of the metadata. We need to add one for funders also. That's becoming important for people like to have that there for links to the NSF and so on. Then the way that you sort of Google likes to find the data is if you have an XML file with all of the landing pages. We'll read that, go to the landing pages, read the headers, and then process that and put it into its search system. So this is, again, the description, sort of a description of what data set search does. Grabs your metadata. If you search on Steens Mountain, say, you get a list of various repositories with that search phrase. We're one of them, but there are other ones listed here. And then there's a map and a link to the data set and more information. So as this becomes more popular, it's a good way to expose your data to the world. We also worked with the EarthCube Geocodes project, where they're also indexing various data repositories through their search engine. And so we were involved with that project, and it's nice to have other portals that are searching over our data sets too. So I just was going to highlight one thing here, that sort of science-on-schema.org is currently been discussing and hasn't come to a good conclusion yet, is how to try to make sure that the data repositories that are the ones actually hosting the data are the ones that get credit and come up on the search in these search portals. So some people will, scrape the, data repositories and put them into their own system. So Data Discovery Studio has done that with Magic. We worked with them, but they're the first on the search return, and they're just they're not hosting the data and are sort of secondary users of the data. And we're still trying to think about if there should be a way for describing the original source or authoritative source, but these are thorny questions and hard to know exactly how to deal with a lot of these more human and political problems than just scientific issues. So that was a little description on how we implemented it, and in the science-on-schema.org cluster, we're happy to give advice and help people with their problems if they want to implement this metadata standard. Thanks a lot. Does anybody have any questions? Let's see.
Looks like we have one in chat.
Okay.
Would data repositories be able to tell from analytics if traffic was driven from the Google Dataset search portal?
I'm not sure. We don't do any tracking like that. Has anybody else done that with their website?
Yes, I should be able to. I think there's a referrer
Right.
tag in the HTTP request, so we should be able to know where the data came from. So I think that's a common way. I think that there should be several ways to track that in the web. Typically, the web server tracks how the requests come in. So on that layer, you should be able to see it.
Thanks, Martin. Aaron?
Yeah, I was just wondering as you went through this process, sort of what was the hardest part, or sort of do you have lessons learned for groups that are maybe thinking about launching on this path?
The hardest, well, a couple of things. One is, I mean, our software system was already reasonably set up to where many of the variables that we wanted to put into the header, many of the fields had already been sort of summarized from the data set. But if you're not doing that already, say the data set has a whole bunch of geologic ages, and now you want to just, you know, put a range into your header. If you're not already calculating that, there will probably be some software backend that you'll have to ramp up to do that. We were already doing that, so most of those were not too difficult to implement. Then just, you know, the standard, you're learning a new language system. And if you're coming from a science background like I was, then sort of understanding how this informatic data structure works and why it's labeled the way it is and so on can be something that takes a little bit of time to learn. If you have someone that's in, you know, knowledge graphs and all that sort of thing already in your group, then, you know, they'll probably be able to jump right in and understand it quite quickly. If you're trying to learn a whole bunch of new concepts, then, you know, these smaller groups, sometimes that's the case, then it may be a little more work. So I think that's the sort of the main thing.
I think, Karen, I don't want to speak too much on behalf of Adam and the cluster, but I know that one idea for the group was to gather a series of vignettes about implementation and different stories of how different groups got started, where they started, and how they moved forward. And I know that balancing that kind of storytelling with, you know, making further updates, hard to juggle, but it seems like a good endeavor.
Yeah, with the recent endorsement from ESIP, quite a bit of effort went into polishing that and getting it into a state of acceptance. And so we feel like, you know, now there's a good documentation and a good idea and a foundation for this. And we've been, I think, focusing a little bit more on adoption. So that's sort of been our focus recently, I think. Let's see. Anybody else?
I'll just ask. Oh, we've got Matt has a hand up.
Well, I was just going to comment on this adoption issue, and we've been trying to onboard various repositories into Data One using schema.org and looking at the implementations that people do. And I can say that we are seeing people struggle a little bit with some of the technical details at various repositories. We're finding records that are not, for example, valid JSON. We're finding records that are missing key fields like the identifier fields or the title field, or somehow malformed. So I think when doing adoption, like one of the easiest, well, maybe not easiest, one of the best things you could do is to try to at least validate one or more of your records against the validator that the cluster produced. And that will let you know that whether or not the record, at least the types of records you're producing, are going to be more easily accessible to harvesters. Because groups like Google, they basically just skip any records that are really malformed, and you don't really necessarily notice it unless you're paying attention to the Google search engine results, the rich results tests that they do. So, so yeah, that paying attention to those technical details still seems like a barrier here, even though this is meant to be lighter weight than standards like ISO, but we're still seeing challenges there.
Thanks, Matt.
So I have a question.
Yeah, Nancy.
Okay. So back with your first talk, so you're making the metadata, you're using science on schema.org to make additional metadata so that it works with Google's search engine for this new project for searching for data sets. So do you have to, you don't have to tell Google what you're doing. You just have your XML headers at the beginning. That gives enough information to Google's generic search setup so that you're not actually working with Google. They just, but it's with your header information, someone can still use Google's dataset search to find your data. Is that right?
I believe the way it worked when we set it up is that you can inform Google dataset search of your sitemap, and then that they will find it more easily in that case. Like they'll search it more often. I'm not sure how it works exactly. Maybe some people from GeoCodes would have a better idea, but I do believe that they may find it just on their general search. But if you interact with them and tell them exactly where your sitemap is, then I think they crawl it more often and will find it more directly.
So you are communicating, so it's
right.
Yeah.
Yeah, you can manually ask Google to map the data set, but yeah, we generally should find it if you have presence on the web, which you will if you're having these web pages.
Okay, thank you.
Sure. Yeah, there's some more answers in the chat if you want to take a look there.
And it looks like there is another question in the chat. Is there an online SOSO validator?
Yes, there is. I guess Doug, maybe you can, or Steve, sort of just, what's the current status of that validator? Is it working pretty well these days?
So, I mean, as Matt mentions in the link,
yeah,
there's there are some, I think some Chrome extensions that David Glayus made that might work with the shackle shapes. The main thing though is that within this context that we're working, there is a way to create validation graphs, shackle shapes, right? That can then look for patterns within the graph. And there are some very nice tools that already exist. In particular, PyShackle would probably be the best one that I'd recommend. And so what you can do then with PyShackle is combine with the shackle shapes that are available at the GitHub repo, you can check your JSON LD data graphs against that shape. There's also some notebooks that we put together that can do it in mass, and so you can get do big checks across the entire collection and get a nice heat map type output. So there are some things that we've done along those lines within the GeoCodes group, for example. But yeah, the main thing would be to utilize those shackle shapes. You can go to I think it's validate.schema.org. That will simply check it against schema.org domains and ranges there. It's a good check to do, but it doesn't necessarily mean that you're in line with the patterns that have been expressed by the Science on Schema group.
Thanks, Doug.
Can I ask if others, I don't see other hands up right now. For those groups that have implemented this, what has been the primary motivator for doing it? Is it the Google dataset searchability? Is it getting into a GeoCodes or another specific search capability.
Well, I can speak for Magic there. We were interested in being in these various search engines, but also we were thinking about how other groups could scan our metadata and use them, like MacroStrat. So we would like our data to be in MacroStrat. Might be easier for them just to use these headers and our sitemap instead of learning our API. So especially before we had an API and we wanted to be on these search engines anyway, it's also access to sharing your metadata with other groups, and sort of like, you know, EarthCube was trying to do a lot of like data sharing and collaboration between these different groups, and that seemed like one way of going about it.
Yeah, from our perspective, from Quasi, I think it was certainly something that helped us to be part of a bigger group. So not doing our own thing, just by exposing our detailed metadata that was not compatible with anybody else, but a standard that we could relatively easily implement. We got help from the project 418 at the time to really help us with that. So I think that was important to really get over the hump quicker. Really being involved with or integrate with the Google dataset, because if we improve the findability through Google, that certainly will make us more fair. So that was one of the big reasons for us to really go with it. Once we dug into it and really spent some time with understanding it, it wasn't so difficult to implement. And then keeping up with the changes that come in. So and it just works fairly well and we use it also in other areas of our ecosystem for the data services within Quasi to inform discovery.
Thanks, Mark. All right, let's see. Okay, well, if we don't have any more questions, we could move over to Kenton's talk.
Okay.
All right. All right, Kenton, thank you.
Assuming everybody can see my slides.
Yeah.
All right, so as Nick mentioned, one of the activities out of EarthCube was this geocodes effort. And so I'm going to talk a little bit about that and what's coming next with regards to its development. So just a little bit about EarthCube for those that don't know. It's a program from NSF that was aimed at basically enhancing cyber infrastructure for the geoscience community. It's been going for more than 10 years now, and it's basically been working to fund and develop efforts that build data resources, infrastructure, workflows, analytics, things like that. And to date, at the end of the program, there's been about 95 efforts funded. A key challenge across all of these efforts, and I would say all of cyber infrastructure in general, is this aspect of sustainability, in the sense that, you know, these things get stood up and then it's kind of difficult to use in terms of finding them and then being able to use them. That's with regards to both data and tools. And so one of the things that was of interest, I would say, fairly early on within EarthCube is how to deal with that. And again, this is not common to EarthCube. This is, I think, something endemic across various cyber infrastructure efforts. And so on the data side, as mentioned, the Council of Data Facilities came together and basically came around this idea of adopting schema.org to basically kind of allow for their collective data holdings to be crawled and indexed and searched, enhancing the discoverability of the geoscience community's data sets out there. And as Nick mentioned, basically all this entailed was, you know, this kind of header on your HTML using JSON LD. You don't have to know the details, but basically it describes what that data is, and giving credit, of course, to the dataset repository, but allowing for something else like Google Dataset Search to basically index it, and somebody could just go there and find relevant data across multiple repositories. So as part of that effort too, the previous office, and then we took it over in terms of taking it a little bit further, was this effort around building a demonstration portal tuned for the specific needs of a community, in this case, the geoscience community. A prototype was set up by the previous office that basically kind of demonstrated how this would work. It crawled the various repositories in this Council of Data Facilities. You could type in a keyword search and get results that spanned across all of them. And so by the end of the entire program, there were some 25, 26 repositories that we and the previous office worked with to adopt Science on Schema, to set it up so that their repositories had the appropriate headers, and they could be indexed and crawled by this GeoCodes demonstration portal, and as well as Google or anything else that crawled schema.org. So that's on the data side of things, and on the tools side of things, there were a number of efforts there as well. The most well-known is the resource registry, where we try to capture various geoscience resources, but also the tools, the software that was associated with it. That was challenging in the sense that it's not really well rewarded in the academic community to go through the process of curating your software and putting it out there yet. It required a lot of handholding. It oftentimes fell on the office itself to actually get that tool in there and the appropriate metadata. Unlike the data side of things, we don't have yet in place, something like schema.org to kind of index that kind of software, although work is in progress on that. And so in terms of sustainability, building out such a resource wasn't sustainable. I mean, if you had to have this central body, this office kind of going out there and manually pulling this data in, it wasn't going to work after the funding ended and the office ended. Whereas with the kind of the schema.org approach, it doesn't really matter if Google's probably not going away anytime soon, but if Google went away, anything else could come in, geocodes, you name it, something else, and serve as that kind of crawler across the data sets. So one of the things we did was explore different ways to kind of address this, to make it more sustainable, to kind of bring the tools into the data as well. One of the ideas we had fairly early on in the last office was the idea of motivating the scientific community to want to put their software out there in a usable manner and findable manner. And so with the rise of notebooks amongst various scientific communities, and advice from a colleague suggesting that one way to motivate the scientific community is to add a peer review aspect to these things so that they could be part of a CV and part of a career growth. We tried the idea of, instead of doing a call for posters and papers at our annual meetings, to do a call for notebooks instead. And so the idea was the notebook was the paper. And in that way, the notebook captured the documentation around the tool, and also ideally in a manner that allowed it to be run. So we experimented with this in 2020. We weren't sure if it was going to work, but we were pleasantly surprised that there was a lot of interest with regards to that. We had 21 submissions that first year, and so we put together a review team with 2 to 3 reviewers per notebook and ended up accepting 12 of those. We worked with AGU on the get-go to actually publish those in their eSource system at that time, so they've got DOI from there, and the notebook could be found there. We learned a lot of things, specifics around, if this software aspect is now important, it needs to be able to run. And this led to changes over the years to asking folks to also include, to actually use something like Binder, which allowed it to be run straight from the web. That first year was kind of difficult for the reviewers in terms of, installing dependencies and debugging. And so that's not something that we want to see long-term. And so we did stuff like that. We imposed a template like normal publications. You have a template for the style for the proceedings or the journal. And so we imposed one as well, making the notebook look really like a paper with an abstract, intro and so forth, and citations. And other aspects. We saw right off the bat that there were kind of 2 flavors of papers. One's very science-driven, where similar software was used across different scientific questions, and others, which we thought would be the main thing, but it was also just part of it, papers as notebooks highlighting software and how it enables scientific research within geoscience. So we continued this in 2021 and 2022. And the results continued to be good. There was still a lot of community interest. We expanded to not just allow for Jupyter submissions, but allow for R and MATLAB live scripts as well. And overall, over those 3 years, we ended up receiving 81 different notebook submissions and accepting 43 of them. In later years, we started using Jupyter Book to publish these as kind of a virtual online proceedings. And you can access all of those off the EarthCube webpage. And the idea here is that the ideas would be carried on by others. Since this kind of thing seemed to have community appeal, there was a way of getting software documented in a usable manner out there so that people can discover and use it. And so basically, we then took the step of revamping the prototype geocodes. One of the tasks for the last office was to get it to a more production level quality so it could be used. And so as part of that, we brought in a UI UX team to really help with that. UI UX is becoming more recognized as an important thing within scientific software, making it more usable and intuitive. And so our team with Lisa Gasky kind of did that with us, working with the EarthCube Leadership Council to kind of define how the workflow should be and what data should be highlighted, what fields should be kind of minimized at first, and kind of making it easy to work with. And the whole theme of the geocodes was around combining the aspect of not just the data, but the tools with the data. The data is only useful if you have the tools along with it. And it didn't really make sense to have two separate kind of repositories, one for data, one for tools. Why not just combine the two together? And so that's what we did. And so when you do a search now on geocodes, you search across both of those things. And pulling from the resource registry and other resources for tools as well. So for example, you could go into it and type in a query, and you'll get back a number of results across different repositories. And it kind of highlights at the bottom whether it's data or a tool. And it also shows if there are connected tools to that data with the potential to using those tools on that data when you download it. If you click on a particular data set, it gives you the metadata, where it's located at, and so forth. If you scroll down, you could see any of the connected tools, downloadable tools, or web application tools, which you can open up straight from the browser as well. And also notebooks that are attached to it as well. So you can just open up them there as well. And we try to provide a template notebook for each data set when possible, just basically a blank notebook that loads the data set in for you so you can start working with it more easily. And so what came out of this, in terms of EarthCube, was really more about best practices. And so the Leadership Council from EarthCube and the Technical Architecture Committee put together this document, which we published, which really emphasized, basically not any particular piece of software, but the approaches that one should take that are sustainable post any kind of funding. And so that's, for example, schema.org, adoption of that, leveraging resources like GitHub and Docker and Binder, and Jupyter, and so forth. So that pretty much wraps up the EarthCube initiative. We had our retrospective at AGU a couple months back. A lot of old faces came back together to kind of rejoin and see how things had progressed. But what's to come after that? So one aspect is AGU. Shelley's on the meeting here today. Put in a grant with the Sloan Foundation to kind of pioneer this aspect of notebooks as the scholarly object, notebooks as the paper, not as a supplement attached to a paper, but as the paper, and really to put together with other publishers like Wiley the recipe book of how a publisher would do this. What is the procedure for accepting these papers, hosting these notebooks, not papers, and so forth. And so it's a 2-year effort, and members of EarthCube like myself will be participating in this to kind of document this and hopefully roll it out so that in the future publishers will be accepting notebooks as well as papers, traditional papers. So that's one aspect that's carrying forward with regards to that. We're hoping to see notebooks kind of serving as the scholarly object across a number of other venues as well. And then there's the aspect of geocodes in general. So as mentioned, this was driven by the Council of Data Facilities and their adoption of schema.org and Science on Schema. But there is other interest as well, as it was mentioned, I believe, by Doug. There's other communities within the Internet of Water and Polder and others that have already started using Gleaner and other aspects for their work. And there's also other needs out there. There was a workshop some years back where the low temperature geochemical community came together, describing their challenges and challenges that could very easily be met by what the work of EarthCube and the CDF did with adopting something like schema.org. And so what we did was a number of us in the EarthCube office put together a CSSI to kind of drive the geocodes efforts to its next iteration. And in this case, really across different domains, not just the geoscience community, but also like ecological forecasting, the low temperature geochemical community, and deep ocean community as well. And being that it's basically not just geo anymore, we renamed it to DeCODER, which stands for this right here, democratize cyber infrastructure for enabling research. And also this is complemented by another proposal in RCN that really focuses on community building around AI readiness and tools built around AI and machine learning. And so the two efforts are working pretty closely together in terms of next steps. So this is the team for the DeCODER effort. And what we're planning to do is carry on a lot of the work we did as part of geocodes and the tech team within EarthCube is a lot, again, really working hand in hand with the community, with the repository holders, and to basically make it so that their repositories provide those schema.org headers so that they can be indexed and crawled. Some of the tasks we have for ourselves and our goals are with regards to the Gleaner aspect, which actually is the thing that indexes these data sets behind the scenes, building a community around that since we have interest there from other groups. Extending, as Karen mentioned, schema.org to deal with some of the variables that are needed for other communities, like depth with regards to ocean data, and in the ecological forecasting community, horizon, basically how far into the future they're trying to predict, something that they need to capture as well. We're planning on basically making it that geocodes framework more easily customizable. Again, the idea is it's kind of just an exemplar of what can be done with this kind of repositories that have schema.org. And the idea is to allow people to basically take it, stand up their own index specific to their community, their own portal, and customize it as need be with their own visualizations, with their own tools and so forth. And so the idea is to stand one up for each of our 3 use cases, ecological forecasting, geochemical, and deep oceans, and so forth. And then with regards to leveraging more of the graph search aspects of what we're doing, bringing in some semantic aspects, and then much more along the lines of linking tools and data as well. So having these calls for notebooks across some of these venues for these other domains, we seem to be in the right place at the right time, perhaps, for the ecological forecasting community. They do these challenges with neon data where people submit their forecasts and then they have to be kept around for years until you can verify the forecast because it's in the future. And so the idea of capturing those executables as notebooks as part of these challenges and publishing them as notebooks is an interesting approach that we will be exploring as part of that. And then lastly, with the communities like the geochemical community, really emphasizing supporting these smaller repositories. There seems to be dozens upon dozens, if not hundreds, of small repositories within that community where it's basically some server that some scientist owns and is maintaining themselves that hosts these data sets. And so building tools to help with that. For those familiar with Magic, they touch on that as well. So we're looking into possibly leveraging that tool for that community. So I think I'll conclude there, but the idea is to really kind of carry on and extend what we've done with the geocodes and continue on the adoption of schema.org as part of these dataset repositories. Are there any questions?
Thanks, Kenton. Yeah, any questions? Well, I have one about the grant. So I guess you've partnered with some communities to sort of help them with the setting up a sort of a search portal. Is it planned also to sort of have some documentation and various things for so it's easier for other people to use the system to set up their own?
Yeah, that is part of the plan. We've been working on that even right now to kind of improve the documentation around these tools, and we will continue to do that. And I suspect, a lot of these, the oceans community, for example, overlaps with the geoscience community. And so we'll continue to work with those repositories, I suspect. The main idea is to really, I think, spearhead this adoption widely across scientific repositories of schema.org. Because that's really the way that's sustainable. Is the adoption of any particular software is not sustainable. It'll go away eventually. The adoption of protocol is the way to go. Just that's the evolution of the web. You have HTTP and TCP/IP, and browsers change over time, servers change over time. It doesn't matter to the customer. It doesn't matter to the user.
Anybody else? Well, we might be ending a little early today because one of our talks wasn't in the program. Karen, do you have anything you'd like to add to the session at this point?
Just a closing thought or two. Let's give people a final moment to, if they have questions or comments on Kenton's talk. Sometimes it takes people a minute to find their mute button and all that. Nope, we're good. I guess maybe we should let people know that if they're interested in the Council of Data Facilities, if they haven't joined yet, and it's something that sounds like it would be of interest to them, it is a completely open group. You don't have to be representing a particular data facility. You can come on by and just join in, learn from us. We cover a variety of different topics. And Megan or Nick, can you remind me if people do want to get on the mailing list, what is
Megan's
the
got
process
the link
now?
here
Click the link in the chat.
Oh, right there. Awesome. Yes.
And we welcome any lurkers there as well, even if you're just a little bit interested in what the future might hold, or don't hesitate to no RSVP necessary to show up to the next meeting and just check it out and share what you're thinking about. I do want to take one step back because I see there was a question that came in from Rob Baker right as we were having this discussion. I wonder, it looks like Rob said we've been starting to use EML, which isn't at schema.org. Is there any larger movement to unify these disparate schemas?
So I'm not aware of any current projects. Anybody else?
Yeah, this is John. I wouldn't use the word unify. I'm thinking of what Matt said earlier, that there is a way to code a reference to your EML from your schema.org and vice versa, I suppose. And doing that sort of referencing, but also the crosswalking between the fields in EML and the fields in schema.org is something that would be useful.
Yeah, this is Matt Jones. I also agree with what John just said. We use EML as one of our primary metadata standards in our repositories and help author and maintain that metadata standard, and can say that it's quite a bit deeper and more detailed than what is present in schema.org, and it fits a different purpose. There is a very strong crosswalk between the two vocabularies, and it's very easy to map, especially the schema.org level fields into it. In many of the languages that we work within, we have, for example, a JSON-LD representation of EML that you can get. So it's fairly easy to move from one vocabulary to the other and to mix and match. Some of our tooling even used JSON-LD tools for doing that kind of crosswalking. So yeah, it is one of those cases where I think they're meant to be complementary and not necessarily, translated one to the other. The ecological forecasting community that Kenton mentioned is a great example. They're using ecological metadata language as the primary language for representing forecast models and model outputs from forecast models. And they've developed extensions to EML that are specific to that kind of forecasting community that I think would be harder to develop in schema.org. So I don't think we want to sort of view schema.org as the new one vocabulary that's going to rule them all. I think there are many different vocabularies that have evolved over the years in the metadata community. We need to support all of them. And I hope that indexers, like at Data One, we support 12 or 15 different metadata standards specifically because they all have their uses. And I think it's very helpful for harvesters to be supporting multiple and treating the schema.org entry as just as a gateway into the richer metadata world that repositories expose.
Thank you, Matt and Nick and John. Please, thank you for sharing links Rob has asked for in the chat if you can. And then I don't want to lose it either. Mark has asked if there are any NASA facilities involved with CDF.
Not that there has been, but I'm not sure if there are any active members at the moment. I'd have to go back and check through the list again. Yeah, we had JPL at one point, but I haven't seen their representative recently. Okay, yeah. Okay. Well, thanks everybody for coming to our session. Again, there's, if you're interested in more details or a different perspective, there's that scienceonschema.org session tomorrow. So I encourage people to check that one out. Anything else, Megan, do you think we do here at the end?
Thank you. Thank you everyone for showing up. It was really great to talk about CDF, talk about schema.org, and lots to follow up on.
Yeah. Thanks a lot.